Hello, my name is Louis Lira, and welcome to my PowerPoint presentation for the use of individual, centralized, and distributed control systems. In this presentation, I will be given the definition of individualized, centralized, and distributed control systems, as well as examples, advantages, and disadvantages of these control systems. I will also be discussing the definition of a closed loop control system, as well as the examples, advantages, and disadvantages of this control system. I will be explaining how individual, centralized, and distributed control systems shapes the ways PLCs manage tasks. I'll compare their advantages, disadvantages, typical uses, and the impact these control systems have over modern industry. Centralized control systems are characterized by a single control unit, often referred to as a central controller, which manages and processes all the data from the entire system. Distributed control systems consist of multiple controllers that are spread out through the system. Each controller operates semi-autonomously, handling specific functions or areas while communicating with others as necessary. Individual controllers, on the other hand, referred to as a localized software design where a single piece of equipment, machine, or process loop, such as a single motor, valve, or temperature controller, is programmed to operate independently of the overarching plant-wide system. Some examples of these control systems include Bitcoin. For individual control systems, Bitcoin is a great example of individual control. It operates without a central bank server or single entity in charge. Instead, thousands of independent computers or nodes across the globe communicate and agree on transactions, ensuring no single party has the power to alter the system. This is very important, especially when dealing with hackers and anybody that can break into the system, um, dealing with money. Uh, yeah. For centralized control systems, my example was Tesla. Car plants like Tesla use centralized PLCs for managing stamping presses, paint lines, and robotic assembly. I've personally witnessed this working at Tesla. They have so many different departments, and every department has different control systems that they use for specific machines. For distributed control systems, water and waste management, or water and waste treatment facilities are a good example for this. Water and wastewater treatment facilities use multiple PLCs positioned near distinct process areas, such as chemical dosing, filtration systems, and pumping stations. Each localized PLC independently manages its specific zone. This is kind of like Tesla, um, while continuously communicating together. Some pros and cons for these control systems, like individual control. It offers personalized management, allowing for quick, specific adjustments, ideal for small scale or specialized applications, but can lack coordination and scalability. For centralized control, it provides unified oversight, ensuring consistency and easier management or larger systems. However, it can be a single point of failure and may become inefficient as systems grow. For distributed control, it enhances reliability and scalability by decentralizing decision making. It allows local responses, but can be more complex to design and maintain. A closed loop control system or a feedback control system is a system that automatically regulates its own behavior to achieve a desired target state. It does this by continuously measuring its actual output using sensors and comparing it against the desired input, making real-time adjustments to minimize any errors. Right here, I have an example of schematics or a setup configuration for a closed loop control system for a dryer. At the end, at the left side, we have a desired dryness. This is our set point. Um, then we have our controller. We have electrical energy going into that controller, making it operational. From the controller, sends a signal to the heating elements that heats the clothes. The actual dryness is our output. The the actual output is then sent as a feedback signal back to the sensor, sending an error signal back to the controller, while our input, our set point, readjusts that error and sends a signal back to our heating elements, continuing that closed loop cycle. Another good example of a closed loop control system would be a home thermostat. A home thermostat continuously measures room temperature with a sensor and uses that feedback to automatically adjust the heater or air conditioner. This turns them on or off to match your desired temperature. This doesn't require human intervention, which means that we don't have to manually tweak these thermostats every time that we want the temperature to go up or to go down. This eliminates a lot of human intervention. You still have to set it, but it saves us time from having to go back and forth. And this is the same kind of um, same way that our industry works. Whenever they use closed loop control systems, you're really just trying to eliminate that human intervention, trying to eliminate those manual tweaks so that way we have more time to do other things that are more important at our place of work. This makes production flow a lot faster for sure. Now, some advantages and disadvantages of closed loop control system. Uh, are like high accuracy because it continuously monitors and adjusts its output. Errors are significantly reduced. Also, automation and adaptability. It operates automatically and is well suited for adjusting to variable inputs or system wear over time. Now, our disadvantages potential for slower response. Processing feedback signals can sometimes result in slower response times compared to simple open loop systems. Another disadvantage would be stability risk. If the feedback is not tuned correctly, the system may be overcorrect, leading to oscillation or runaway conditions. In conclusion, individual, centralized, and distributed control systems form the backbone of modern manufacturing. Without these control systems, we would rely a lot more on manual oversight, meaning workers would be managing tasks that are normally automated, making production results less predictable. These controls help maintain efficiency and quality. They maintain consistency and reduce error.